In question 4, we're given this information for an arithmetic sequence. I would start by summarising that. So U1 is 14, U4 is 32, and I'd write down my nth term of the sequence. UN is A plus N minus 1D. So from our first term here, U1, well, my first term is A plus 0D, so just A. My first term is 14, and here my fourth term would be A plus 3D, which is 32. I plug the top one, A is 14, into the second equation and solve it to find D. It's worth doing a mental check then. If I start with 14 and keep adding 6, my fourth term should be 32, which it is. So again, a really common question. We're given two different terms in the sequence, and then we're asked to find some more information. Our first step is to translate these into equations involving A and D. So for our third term being 30, our third term is A plus 2D, that equals 30, and then our ninth term is A plus 8D equals 9. It's always going to have this format. We're going to subtract one from the other. So here I'm going to do equation 2, take away equation 1 to leave me with 6D is minus 21, and therefore D is minus 3.5. Now here we're asked for the first negative term in the sequence. At the moment we're up to U9 is 9, and we're subtracting 3.5 each time. It's not going to take us long to get to a negative term. So possibly most efficient here would be to just write down what U9, U10, 11 and so on would be. And very quickly we get to U12, our 12th term in the sequence is negative 1.5. So that's our answer, our first negative term in the sequence. Now you wouldn't want to do it that way if, for example, we were at a term here, U9 equals 9,000 and something, or a huge number. We don't want to sit and write it all out, so we need the algebraic method. So what we would do here is use D, plug it in to work out A, and then you've got your expression for the nth term, A plus N minus 1D. Simplify that and then find the first, the value of N, which is going to make that negative. Okay, so I'll just do that here. So plug D into equation 1, I get A minus 7 is 30, A is 37. Quick check mentally or calculator, and that works in equation 2. Now put it into our nth term formula. Using those values for A and D, A is 37, D is minus 3.5, plug them in and we get 40.5 minus 3.5n is the nth term of our sequence. We want the first negative term, so when 40.5 minus 3.5n is less than 0, and then we solve that. We get n is greater than 11.57, blah, 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 and then n must be a whole number, so we're looking at when n equals 12. We then plug that into our rule for the nth term to find what that negative term is. And of course we get the same answer. So clearly this first method here, because we've only got a few more differences to go, a few more terms, is our most efficient. So question 7, exactly the same format. If you pause the video now and give this one a go, and then you can restart the video and check your answer. So the first marks for these two equations, the 20th term is A plus 19D, the 40th term is A plus 39D. Solve these equations simultaneously. We first find that D is minus 1. That should be no surprise actually, because it shows us that we're a decreasing sequence. My 20th term was positive 14. By the time I've got to 40th, it's negative 6. So clearly we must be going down. plug that in to find A. Find A is 33, and then a quick mental check in equation 2 shows that works as well. Value of the 10th term, so writing that as A plus n minus 1d, and then plugging in for our 10th term, and we get u of 10 must be 24. Okay, in question 8, there's a couple of things I could do with the information here. First thing, I could write each of these first, second and third term in terms of A plus n minus 1d. And I get these three equations, and I could work with trying to solve these in some way. Equally, I could recognise that if I did 20 minus 5p, that must be my common difference. And if I did 3p minus 20, that must also be my common difference. Now, if that's my difference and that's my difference, then these two things must be equal. So I must get 20 minus 5p equals 3p minus 20. You get the same kind of thing if you work with that over there, but this is probably a bit easier. So we'll end up with add 20, we'll get 40. Add the 5p, we get 8p, and we'll get 5 equals p. Okay. We could then plug this back in. 5p, so our first term is 25, our second term is 20, third term is 3p, which is 15. And we can immediately see actually the nth term of this must be minus 5n plus 30. You can write that down straight away. And the 20th term must be minus 5 times 20 plus 30, and that gives us minus 70. Okay. Possibly what you've done is if you're working with this set of equations over here, you could have plugged A is 5p into this one, and that would give 5p plus d equals 20. You could have also plugged it into here, potentially to give 5p plus 2d equals 3p. There's a few different things you could have done with these, but perhaps this. You could subtract one from the other. 5p minus 5p disappears. 2d minus d gives us d is 3p minus 20. What could we do with this? Well, potentially you could plug it back in here, d, to get a single equation just in terms of p. So 5p plus 3p minus 20 equals 20. That gives us our 8p equals 40, and so on. Okay, not quite sure where your p being minus 5 has come from. It might be that you've confused. So p is just the value here. Don't confuse the minus 5 as the difference. Minus 5 is our difference d. We would have our first term a would be 25, and our difference d would be minus 5. Hope that helps. So having read your question again, I'm not sure where you've got 120 from, possibly using this, but if we carry on and use this, a plus n minus 1d would give us, and we want the 20th term, would give us a plus 19d, which would be 25 plus 19 times negative 5, which does also give us this minus 70. So I think your 120 must have been an arithmetic error somewhere. Just note the difference here. P was the 5, and it led to a sequence with a difference of minus 5.